Okay, today is about horizontal asymptotes. You will need your iPads out. You will need to find the file that is up on the board right there. It's today's date, 12-18. You can find it there. It's called horizontal asymptotes. You might be thinking, we already did those. A little too much talking. Thank you. Can you not do that right now? Thank you. All right. So I want you to get into the mindset of the test. You know the test is coming soon. It's not tomorrow, but it's Thursday. I want to give you a little bit of review to chew on, but I wanted to get you moving on this first to find it. Just a quick show your iPads. Let me see how many of you are in the right spot. Quickly, turn your iPads my way. And I see I am at about 40% right now, so I'll give you a little bit more time. Okay. Question. Raise your hand if you have a question, and I will call on you. Yes? There are completed notes, but you don't have to have them up. Oh, the regular ones aren't up. Okay, I'm going to pause for a second. Go. All right. I want to make it clear why we're talking about horizontal asymptotes again, because you've done them. Because we have only done a certain kind. You guys have already talked about finding holes and vertical asymptotes, and we've done horizontals. But the horizontals that we did were always only a certain kind. They were only when the function would look like this. That kind, you'd be able to tell me by picturing where it moved, okay? And you'd be able to tell me the horizontal asymptotes on that. I'm just going to review that for a second and say, do you remember that the parent kind of looked like that? And then this one means move it which way? To the left. How far? 4. And then what's this? Down 7. So left 4, down 7. Again, judgment call on exactly how far down to move it. But I think you can see the horizontal asymptote moved, and we've already talked about it in that context, right? But to do that, you got to like go through a whole bunch of work to figure out where that horizontal asymptote went. I have a few tricks for this. That's the x-axis, but it's y equals 0, except it's been moved. Where did it move? To -7, so y equals -7. That's the horizontal. Remember me doing that before? Because every now and then they're just going to say x equals 6, and you're like, what does that mean? Oh, it's a vertical asymptote. Or the y equals ones are horizontals, and the x equals ones are verticals. So this one's an x equals 1. Would you please figure out what it would be for this problem right here? And then we'll talk about why that won't always work for your horizontal asymptotes. All right, this is the y-axis, so it's not y equals 0, it's x equals 0, but it got moved over here, so it should have been at x equals, raise your hand if you think you know. There's really only 4 people? All right, what do you think, Miss P? -4. How many of you thought it was -4? Okay, good. How come I didn't have that many hands before? Come on, chickens. All right, so which of those was the horizontal? Oh, it's the y equals 1, Mr. Server, because it's the horizontal asymptote. All right, so why don't those always work? Because they get more complicated than this. Of course, that's about as simple as they could get. We started to delve into things like this the other day. That kind of thing. And I would say things like, if you can factor it, you should. But we never even talked about what the horizontal asymptotes of that would be. But I can tell you how to find the horizontal asymptotes for something like that. That's the goal, is for today, how on earth would you find the horizontal asymptotes for it? Well, first of all, do you remember the saying, if you can factor it, you should? All right. And yeah, I'm going to save you some time. You can't factor the top one, but you can factor the bottom one. Would you please factor the bottom? Megan Trainor would agree that it's all about the base. The base, this thing on the bottom, tells you so much. It tells you the domain. And It tells you the holes, if there are any, and it tells you the vertical asymptotes. The only thing it doesn't tell you is it won't tell you the horizontals. Okay, so this has got like 3/4 of your test is about that. Because again, that's got the verticals in it, which would be x equals -5, and what's the other one? X equals -1. If the top had factored, and imagine a world in which it had factored and there was an x plus 1 in it, do you get that would have created a what? A hole. Very good. And if there was nothing to cancel, then there's 2 asymptotes. Do you remember us exploring that there could be 2 vertical asymptotes? Like that one would have 2 vertical asymptotes. And it's okay. The graphs are strange looking. This would have an asymptote at -5 and at -1. And then the rest of the graph, you'll see some examples in the notes for today, kind of goes around those asymptotes. One of the key things for today is that the asymptotes attract the function. The function flies to the asymptote. It wants to touch it, but it can't. It gets really, really close, but it can't touch it. It's kind of like a moth to the flame, except they actually sometimes do fly into the flame. Maybe the science teacher can tell us, why do the moths fly towards the light? Towards the, maybe that's not your area of science. I don't know. You could make up something for me? Okay, thanks for being honest. I've heard it's something about their navigation system. That's all I. Does that seem logical? Seem believable?
I think it's the heat.
You think it's the heat?
Part of the heat of it, yeah, light.
Okay. Yes.
It is the navigation.
And the navigation.
They use like the sun as navigation.
Because they think it's like the sun and they want to. It makes me feel, but the only flaw in that to me is it seems like that means that every moth would always be flying towards the sun. You know what I mean? That doesn't seem right. They wouldn't last very long. Yes. See, sounds very scientific. I know. Oh, so they're used to flying at an angle to the sun or the moon. And then that's how they navigate. And then when they fly by something that's really close to them, the angle changes super fast, which throws off their navigation system. Cool, we learned something. It wasn't directly related to what we're talking about, except this. This is important. When there's asymptotes, the graph has to get closer and closer and never touch. Okay? It wants to get closer and closer and closer to those. So if there's asymptotes, I know that affects how this story ends. The graph will have to get closer and closer to that as it goes on. Okay, so if it didn't, then it would be breaking all the rules of what asymptotes are. They attract the function. Function wants to get closer and closer to them. All right, so now let's talk about what don't you know? You don't know how to find a horizontal asymptote when it's not a simple one. All right, so then we're going to generalize a pattern for it. And we're going to give you a graph, and you have to write the equation. That's the most advanced kind. The cool part is, big picture, this is the last new stuff. And then we review tomorrow. I'll review everything. You can ask me anything from the whole unit. And I know where the weakest spots are, and I will push you where you're weak. Be like your personal trainer. Okay? Because I don't need to practice all the easy ones. You already can do that. So we'll try, and we'll push you pretty hard during the review day. And then if there's anything you don't understand, remember that my help days are Wednesday mornings. And since this test is happening on a Thursday, you could come in Wednesday morning if ahead of time, or Thursday morning. Both those days work. Wednesday during Mass, it's an open invitation day for me. And Thursday, you can also get extra help then. All right, so I'm going to cut to it. Here is a typical, a typical fill in the blank that they would want you to know, which is horizontal asymptotes describe the blank of a test, of a graph, sorry. They describe how the story ends, the end value. Okay, I would like you to put in end value here in your notes. So do you get that if it's got an asymptote here, that means eventually the function will be really close to that? Even if there wasn't a picture here, even if there was no picture, you could say, I know when I get way over to the right, it'll eventually end up almost touching that dotted line. Even if you didn't know that it really looked like this, you'd know that at the end, way on the right, it must be getting infinitely close to that. Okay, and way on the left, eventually, when you go far enough left, it has to be pretty much touching that line. That's what those horizontal asymptotes tell us. All right, moving on. So as you look at this, do you get if I take this and go way to the right, I get to write something for you that looks really mathy, and it'll be your first exposure to a limit. The limit of this function as x approaches infinity, that means if I go way to the right, it gets infinitely close to a y value of 0. Have you done that before? Have you done limits like that before? Okay. I get to be the first person to show you. Cool. Because I guarantee you're going to learn that in pre-calc next year. And you're going to use it on 3-4 tests on pre-calc. And then you're going to use it again in calculus, etc. That's your first limit. Can anybody, even with just that brief exposure, tell me what limit I could write for the left side of this particular function? Yes, sir? X approaches negative infinity. It'll equal 0. Very good. All right. Why? Because way over here, x will approach negative infinity, won't it? That's the left side. And then what will y be? The height of your graph. See the graph? It's pretty much on 0. But we know from the context here that there's an asymptote line there. It's just getting infinitely close to 0, but not actually touching it. All right. Now, I want you to look at these. There's 3 functions here. And this one goes with this one. This one goes with this one. And this one goes with this one. How could I have predicted what the asymptote would have been? I'll tell you. This goes to the concept of degree. This one has a degree of 2 because 2 was the biggest power on the variable. The bottom of it has a degree of 3. So this one's bigger on the bottom. It's a bob. If it isn't bigger on the bottom, it would have had to have been bigger on top. That would be a bot. Or they could have had the same degree on the top and the bottom, and that would be an SOB. Same on both. I don't know what you were thinking of. All right, so notice these, all 3 of them are bigger on the bottom. It's about the degree. It's not about the lead coefficient. That's different. It's about the degree. All right, so let's step back and just talk about degree for a minute. What's the degree on the top? What's the degree on the bottom? Even though there wasn't a 1 showing? Yeah, you're right. Hint. Think about it. What's the degree on the bottom? 2. Very good. I didn't fool you a bit. Because you'd have to multiply it out and you'd have an x squared in it, so degree is 2 on the bottom. Would you agree it's still bigger on the top? All right. So there's a rule for that. Bigger on tops are one thing for their horizontal asymptotes. Bigger on the bottom is different. And if they're the same on both, that's something else. So I got to get you to memorize these 3 things. If they are bigger on top, try to remember no-bot. It's like robot. No-bot. What do you think the no stands for? In the context of an asymptote, what do you think that would mean? There's no asymptote. There had to be one of these that would have no asymptote. This one doesn't have any horizontal asymptote. It's got 2 vertical asymptotes, x could crash it by being -2 or -5. So it has two verticals, but no horizontals. I think you'll get the hang of this after a while. So it's bigger on bottom, bigger on top, or same on both. Please don't talk to each other, guys. If you have something to ask me. All right, next one. Is that bigger on top, bigger on bottom, or same on both? Bigger on the bottom. Bob is usually a 0. And these are y asymptotes. Y equals horizontal. Remember, this is all about horizontal asymptotes. That's all about y equals things. And they're usually 0. That's not good. So like how do I tell if it's not 0? The only way it's not going to be 0 is if they move the whole thing up like 3. Do you get if I move the whole thing up 3, the horizontal asymptote would have to move up? Now, some people don't even teach this because it adds complication, but I think you can handle it. Some people just say, if they're bigger on the bottom, it's y equals 0. But what if you moved it up 3? Then it wouldn't be y equals 0. It would be y equals 3. 3, not -3. You can trust the stuff on the outside. Y equals 3. The whole thing would move up 3, so the horizontal asymptote would be 3. So I like to say that the Bobs are outsiders. Are they still reading the book, The Outsiders, in English classes? All right. I don't mean like this year. I mean like in high school, did you read it? I read it in high school.
We read it in middle school.
Middle school. Okay, fine. You guys are smarter than we were. Anyways, so Bob's an outsider. You cry when Lenny? All right, anyway. Okay. So Bob's an outsider. Let me give you another example of a Bob. But I think you can handle it, so I'm going to go like this. Now, I know some of you are going to mess up a little thing. Write what you think the asymptote is and turn it my way, and I'll tell you yes or no. I'll either tell you yes, you got it, or no, you didn't. Make sure you zoom in on it because I'm old. My eyes. I used to have 2015. Yes, 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 yes. Now I know it's easy for some of you. Yes, to hide. Yes, when I do that. So the people that didn't answer, what do you think the most common mistake is on this? Well, probably just not knowing at all what to do. Well, what's the first step? You figure out if it's bigger on bottom, bigger on top, same on both, right? What was this one? Bigger on the bottom. And you have to memorize that Bob is usually what? A 0. So I could see people saying 0 by accident. Instead, it's -8. I did see one person who had an 8, and I didn't want to embarrass them, so I said yes. But whoever you were, why isn't it -8? It doesn't have to be the person that said it. Why do you think they thought it was -8? You can trust the out. I think I just said that backwards. So that's why everybody's looking confused right now. The right answer is -8. Somebody said 8, not -8. And the person who said 8, I think they were thinking, oh, don't trust but it's on the outside. You can trust it. It is y equals -8. All right, that's enough about Bobs. And you remember about bots? No bots? So if it was bigger on top, the answer is just no. Doesn't have a horizontal asymptote. Okay? No. None. You can say no, and it'll be fine. It's the only time it's good to have Mr. Survey ask you a question, and you say no. All right. How about, what's the kind we haven't talked about yet? SOBs. Same on both. This is one of those rare times where it really doesn't matter if you factor it. It won't change the horizontal asymptotes. You don't have to factor them to get this. Factoring is always good, but this one is the same on both. And I'm going to tell you what the asymptote is, and I'm going to let you try to figure out why it's that. I know you don't have enough information yet. I'm going to give you a little more information. If I changed this to be a 2, then the y-intercept, or sorry, the y equals, which is a horizontal asymptote, would be 2. I'm going to change one more thing. If there was a 7 here, then anybody want to predict it? 2 sevenths. Oh, there we go. Okay. Hey, be nice. All right. So it's just freaking you out so bad because he's always right. So, all right. So what if this was a 9 and this was a 3? What do you think the answer is? 9/3, which is 3. All right. Good. That's the SOB kind. They're the hardest ones, so they make you sob when you're doing it. Okay. So, I don't think they're that hard, though. Hint. These are all the same. They're all a certain kind, and I know by looking at their graphs, it can't be the no-bots, right? Because they have asymptotes. I can see where the horizontal asymptotes are. Can you see where the horizontal asymptotes are? All right. And when you first learned about horizontal asymptotes, we said that it can never touch the asymptote. We lied to you. Just a little white lie to make your life easier. I hate to be the one who has to tell you. And I don't know. I'm not going to even tell you about Santa Claus or the Tooth Fairy, but I'm going to tell you about this one. You can touch. Ask your mom. You can touch. Apparently, some substitute teacher at an elementary school. Did you read about that? Some substitute teacher came in and told all the little kids that there was no Santa Claus, and like the parents were pissed. Anyway, so back to. There is an asymptote right there. And I know from watching the movie The Santa Claus that there clearly is one. So, anyway. All right. We used to say that it never touched the asymptote, but if you look at this, do you get it touches here and here? In rare circumstances, they will cross over the asymptote. And it's just like, you don't tell people, like the rule is, look both ways before you cross the street, okay? And technically, if it's a one-way street, you could just look one way, but, mind blown. But you don't tell people that because you'd rather just have them, okay, so anyway. This is the exception to the rule. Sometimes, rarely, they can touch their horizontal asymptote, go through it, in fact. But in the end, what's the point? The point is, it gets closer and closer to that dotted line. Would you agree that eventually it ends up being really close to 10? It's the moth to the flame thing. The function gets closer and closer at the end. And same on this end, it gets closer and closer to 10 at the end, but it does something weird in the middle. It's kind of like in the long run. I would predict that someday you guys will see Dow Jones of 100,000. Okay, and it was at 25,000 recently, for example. So in other words, I think the Dow Jones Industrial Average, which you guys all have seen here and there, you see the stock market's up or the stock market's down. In the long run, I think it's going to go up. But there's going to be a lot of up and down in between. Like each day, it's gone. Like yesterday, it was down 500 points. Do any of you guys follow the stock market? Like maybe mom and dad have invested in some stocks, and you kind of, not many of you pay much attention to it. I can tell. All right. So, well, what's it doing right now? It's green today. It's in the green. All right. Yes.
So if you were given a graph, how would you be able to tell if there was no asymptote?
If there's no asymptote, there's no horizontal line you could draw where it's being attracted to that in the long run.
So if there's both, it's an exception.
This one is the weird exception where it's crossing over there is a horizontal line there. It's just that it would actually cross over it. That's the weird one. To be honest, we don't test you on weird exceptions. So don't worry about that much. I just wanted to tell you because I knew somebody was going to ask me, wait a minute, how can that have an asymptote? Because it's crossing it. In rare circumstances, it can touch the line. But the key is it in the long run. Can you see that in the long run here, this is getting really close to wherever that line is? It's getting really close to that line right there. Okay, losing some of the class. We need to move on. Find this pink page. Gentlemen, I'm okay with the fact you check the stock market in the context, but back with me now. Ready? Okay. All right, and that goes away. This goes away. It'll go off, and then you'll get busted, and then I'd have to take it away. All right. Now, I know some of you, I see some of you doing it. You're like, there's an asymptote here. You're right, but we're not teaching you how to find slant asymptotes. They're actually really complicated. So the only question is, does it have a horizontal, that's the key, asymptote? No. And these are bots, right? Are they bots, bigger on top? And there's no horizontal asymptotes. Yes, there are diagonal asymptotes. Cool thing to know. But you're not going to learn how to do them until next year. So the only question is there a line like this that it gets closer and closer to? And the answer is no. All right, what'd I miss? That wasn't that funny. Okay, that's fine. Okay, fine. All right, so this one, again, it's got a horizontal asymptote right there. But you're not going to be asked to find what it is. You'll only be asked, does it have a horizontal asymptote? And the answer is no. And you could have told just by the fact that it's bigger on top. All right, I feel like you've got this. Let's find out. Fill in what the horizontal asymptote would be for this one, and this one. And if you just write like a number like 5, you're doing it wrong. The whole point of this is a horizontal, which has to be a certain letter, asymptote. Pause for a second while you give that a try. Here's the answers that we got. I wanted to double check them before we released them on the video. So there we go. The top one is a bigger on top, so it's none. And then it was the same on both. So that one's y equals -2 because it's the ratio of the lead coefficients. The last one is the bigger on the bottom, y equals 0. All right. So now we're going to get to our worksheet. I'm going to pause while I pull that. Okay, here we are. Identify the horizontal asymptote. If an asymptote does not exist, write none. All right. So all we really have to ask is it bigger on the top, bigger on the bottom, or same on both? What do you think about A? Same on both. The sob kind, they're always y equals unless they're none, right? So it's y equals, how do you do that kind again? That's the hardest kind. It's the ratio of the lead coefficients. So 2 over, what's the lead number there? There isn't one. 1. 2. Es ist 2. Sprechen Sie Deutsch? Haben Sie Deutsch? Jemand? Nobody? All right. All right. It's not Yaman. All right. Go to B. I'm feeling like it'd be handy if one of these would cancel so I could demonstrate a whole, but it doesn't have that. So, oh, bother. It won't let me erase it. Fine. I'll just deal. So, would you agree that this one, if I multiplied it all out, would be bigger on the bottom? So what's the deal? Generally, they're usually what? 0, unless there's something on the outside of the fraction. Is there anything on the outside of the fraction? No, there's a 0 out there, you could say. So it's y equals 0. All right. And then part C. Random person. You're going to have to figure out if it's bigger on bottom, bigger on top, or same on both. And know what the rule is. You can always look at your notes. It is row 2. Person 5. 1, 2, 3, 4, 5. AE. Destiny likes you today. What should I do? Do I even need to factor on part C? Hint, I know the answer is almost always yes. But for horizontal asymptotes, have you ever seen me care about factoring them? No. So what do you think? Yep. You are correct. Because it's a bot. You do not have to actually write bot on your test. It's just a way of figuring out what the answer is. No bot. Oh, I got to remember I have to write stuff if I don't want it to stay there. All right, moving on. If I was going to pick the most important part of this, gentlemen, if I was going to pick the most important part of the homework, it would be the stuff that it covers like almost everything on the test, it would be problem 2, part A, right there. This is a simple one that covers the meat of the test. Like if you don't get any of these things, you can't get a good score. Okay, you got to get all these things. You got to know what domain is. And you might be like, what? I have to know like what the picture looks like? No. Domain is what you can safely feed the function. And that is one that cares about factoring. So hopefully somebody, some smart kid, has already factored this. Who's got it? Sir. NK. You are so right. And then, ooh, I see something that cancels. Do you know what that means? You were gone, but I bet you do. So what does that mean, though? Exactly, there's a hole. Where? I'll encourage you to always put it in parentheses like this so that you don't, by accident, just say -5. Because -5 is a good start. But it's -5. A hole is a place. It's over and up, right? It's like, now it's an X and it's got a Y. And I warned you that this was the hardest part. GL. Where the heck did you get that? You are right, but how did you do it?
Put the -5 back in for the x's.
All right, and I think it would be smart if kids wrote this. Y equals 1 over x minus 1. Because this simplifies to this with the caveat that it also has a hole in it. But otherwise, this does simplify to this, as long as you remember that there was a hole. So then to find the hole, you put the -5 in, just like he said. And that's how we got -1/6. I know that is the hardest thing on the test, because when I grade these things, that's the thing I have to mark wrong more than anything else. But I'm trying, by emphasizing that to you, trying to make sure that you don't fall victim to that. All right. So that was the hole. Horizontals, you ask Bob. And then you go, is it a Bob, Sob, or a Bot? And then you answer it that way, like we just did. Verticals, I just want to make sure you didn't forget that. Verticals are the things on the bottom that crash it. Like, in this case, x equals, remember, x is vertical, right? X equals things. 1. Why isn't the -5 a vertical asymptote? Because it's a hole. And it can't be. That alarm going off, by the way, means we have 12 minutes left. This is the part where I'm supposed to get you into your homework soon so that you can have some time to work individually and ask me individual questions. All right, anyway, x equals 1 was a vertical asymptote. Why isn't x equals -5? Because it was a hole. There's 2 things crashing this, 1 and -5. One of them does it by being a hole, the other one, asymptote. Last thing, domain. I would just introduce a new way of doing this and saying everything works except 2 things. The hole and the asymptote both don't work in the function. They don't give an answer. So there's 2 things, -5 and +1. And I know some of you are going to be annoyed by me introducing a new way to do this. You're going to say, I'd rather just write -infinity to -5, -5 to 1, and 1 to infinity. But I just want to show you that we accept this notation even in honors pre-calc. We accept number line notation. That would be the same thing as saying this. All right. This is the part where I actually turn you over to you and your homework. Remember the last 2 parts, at the very bottom. I'll show you. You can skip those. I tried to look for other things you could skip, but sadly what that means is that seriously, this test or this review worksheet covers a lot of what's on the test. I could only cross off those 2. And you could save those for the test night if you want some more practice. You could do those. Remember, you got a key for this, right? You could use that as an extra practice for yourself if you need it. Okay. I need to finish this off. So, tell me, what was the topic for the day? Horizontal asymptotes. And was Bob involved? Sure. But Bob's brothers, which are Bot and Sob, also helped out. If it's a Bob, bigger on the bottom, what's the answer usually? 0, unless there's something on the outside. And then if it's a Sob, ratio of the lead coefficients, okay? And if it's a Bot, no. Very good. No bots. All right, that's all I got for you for today. Videos.